guide you through this case. The first law of thermodynamics states that energy cannot be created or be destroyed, but it can be transferred. This means that the electrical energy generated by the solar panel can be transported to the residential area by converting it to any chemical energy to be stored by transporting it via pipelines. Thus, this satisfies the statement of first law of thermodynamics. Based on the scenario, the problem faced are the need to identify suitable chemical to store the chemical energy and the method to convert it. Which leads us to our objective, where we need to first identify suitable chemical to store the chemical energy other than octane, and secondly, to find suitable method to store the electrical energy generated by the solar power plant.
As you know, our company, Evercam, is undergoing an energy crisis. My secretary will brief us further.
So, according to the case study, Evercam ES5 plant has generated electrical energy from Lobster Solar Power Plant located at the desert. Our task is to find chemical energy that's suitable to store the electrical energy so it can be transported to the city located far away from the desert to regenerate electricity for the industrial and residential usage.
What about octane?
Unfortunately, the process of producing octane has been patented by Shell.
Any other ideas, guys?
For now, we don't have any other ideas.
We pay you a lot.
I'm sorry, boss. We'll get to you as soon as possible.
Yeah.
Think harder.
Okay,
boss. Oh man, Sir Aiman's gonna fire us.
I wish I could be as free as a farm.
The farmer? Wait, I got an idea.
Hey Logan, so what's your idea?
Oh, let me introduce to you my genius solution on how to solve our energy problem. I present to you ethanol.
Ethanol? Are you sure?
Yes, and for various reasons. But let's first find out what ethanol is. So, now let us learn about ethanol. So, ethanol is an organic compound which is liquid in room temperature. Here are the facts about ethanol, and here is the molecular structure and its diagram. Now, why are we choosing ethanol? This is for three main reasons. Firstly, availability. Secondly, energy density. And third, it is because it is clean energy. Now, to the point of availability, ethanol is produced from biomass and the fermentation of sugar. So, plants such as corn, barley, wheat, and various types of grasses can be used in the production of ethanol. Next, energy density. Yes, octane does have a slightly higher energy density than ethanol. However, ethanol is still has a higher energy density than most other chemicals, and it also makes up for its slightly lower energy density in forms such as it burns well, is easily stored as is liquid in room temperature, it is safe as it is non-volatile and does not release harmful gases, and it has a neutral smell, so it does not produce unpleasant odors. Lastly, it is clean energy as it does not produce any soot, smoke, or ash, and it produces almost 0% of carbon monoxide when it's improperly burned. On the bright side, ethanol is renewable. It does not deplete as it comes from plants, it produces lower emissions, and it is safer for the environment.
So now, let's talk about how electrical energy is converted to chemical energy through the formation of ethanol from carbon dioxide. So first of all, the solar panel at the solar power plant will convert the solar energy into electrical energy. The solar panels consist of many photovoltaic cells which can absorb sunlight. When the sunlight touches the surface of the solar panel, the photons of the sunlight will excite the photovoltaic cell and causing a current to be created. So next, the electricity generated from the solar panel will be used in the process of electrolysis of water so that we can produce hydrogen gas and oxygen gas. Next, the hydrogen gas is used and combined with the carbon dioxide to form ethanol and water. The process is called hydrogenation, and the process requires the presence of catalysts such as zinc and also copper. And lastly, the ethanol produced will be stored at the ethanol storage or ethanol tank. So to sum things up, the solar panel will convert solar energy into electrical energy, and then the electrical energy will be used in electrolysis of water to produce hydrogen gas. And lastly, the hydrogen gas will combine with carbon dioxide in the atmosphere to produce ethanol. And that's all from me.
Alright, I will be presenting to you the data analysis for this process. So there's two factors that affect the rate of reaction, which is temperature and the presence of catalyst. So for the temperature, you can see from the graph, as the temperature increase, the particle that reach the activation energy will increase. This is because the kinetic energy of the particle also increase. Therefore, the frequency of effective collision increase, then resulting higher rate of reaction. So for the catalyst is actually a substance that will increase the rate of reaction without being used. So you can see from the graph, with the presence of catalyst, it will accelerate the combustion process by lowering its activation energy. So the frequency of effective collision will increase, then the rate of reaction increase. So for the common catalyst that will be used for this reaction is copper and zinc. Alright, let's move on to the delta S, delta H, and the Gibbs free energy equation for this reaction. Alright, so to calculate the delta H, we will use the formula of summation of delta H of product minus with summation of delta H of the reactant. And then we get the delta H equals to negative 1366.7 kilojoule per mole, which is its negative delta H. And then for the delta S, we will use the formula summation of delta S for the product minus summation of delta S for the reactant. And then we get that delta S for this reaction is positive 218.3 kilojoule. And then to calculate the free energy, the Gibbs free energy, we use the formula delta H minus temperature times delta S. And then since our delta H is negative and then our delta S is positive, therefore our delta G will be negative with increasing temperature. And here, with increasing temperature, our delta G for the combustion of ethanol will be negative. Therefore, this reaction is more spontaneous.
Now, let's talk about the kinetic limitations of ethanol. The first kinetic limitation of ethanol is diffusion limitation. You see, for combustion process, fuel and oxygen react with each other at a molecular level. In some cases, insufficient mixing can lead to insufficient oxygen being provided for combustion, hence this will lead to incomplete combustion. Now, let's talk about the second factor of limitations for ethanol, which is equilibrium limitation. See, the main purpose of combustion is to fully oxidize the fuel into carbon dioxide and water. However, challenges that we face are factors such as temperature, pressure, as well as residency time. You see, incomplete combustion can lead to byproducts such as carbon monoxide and unburned hydrocarbons. Now, let's talk about heat loss. In combustion, heat energy is released. However, some of this heat energy may be lost towards the surrounding or towards incomplete combustion. Heat loss in general can reduce the efficiency of combustion process. There are a few steps that we can take to overcome these limitations. The first one is to design a proper combustion chamber so that sufficient mixing is achieved, as well as so that complete combustion is achieved. The next one is optimizing fuel to air ratios so that the desired efficiency of combustion is achieved. The third one is to use a proper ignition system so that reliable ignition is achieved. The fourth one is to promote the use of catalysts so that the rate of reaction is increased, as well as to promote complete combustion. And then the fourth one is to ensure proper maintenance and tuning of the combustion system.
In conclusion, ethanol emerged as a superior alternative to replace octane in terms of store energy in renewable fuel. Its renewable origin came from biomass sources to ensure sustainability without relying on finite fossil fuel. Hence, this also makes production cost lower compared to octane. Octane may have higher energy density compared to ethanol, but it faces many challenges with volatility, flammability, and limited cycle of life. for energy storage. Ethanol is non-volatile, safe to use, and burns well with natural scent. Hence, other than that, in advancement in engine technology and fuel blending technique can overcome the limitations of ethanol. Additionally, ethanol capability with existing infrastructure and potential for domestic production make it a practical choice. Ultimately, since its renewable nature and optimization potential, ethanol stands out as a better option for replacing octane in terms of store energy in renewable fuel.